Okay, today is optional Monday, so we got a lot of people gone today, so we hope that we see you guys back sometime. Today we're going to talk about just one day on 2.4. We're going to test sometime next week. I'm guessing our test next week is going to be around Wednesday, Thursday, somewhere around that time frame, okay? We want to get through 2.5. 2.5 is going to take us a long time. It's a very involved section, very important. But average rate of change is the following. F of B minus F of A over B minus A. And here's what average rate of change kind of tells us, give you a general idea. You see this function that I have here. You can plot a point at -5, -3, and you can plot a point at 4, 2, and then draw just kind of a little curve that goes there. And that'll be sufficient for what we're doing. But if I point to a spot on the curve, do you think I'm on my way up or on my way down at this spot? Because you're moving from left to right, correct? How about here? Am I on my way up or down? Down, and here up or down? Up. So you can see you're moving up, then down, then up. So we would say that the average rate of change here is increasing, and then it is decreasing, and then increasing. Or the average rate of change is positive, negative, and positive. Overall, as I go from the point -5, -3 to the point 4, 2, overall, have I gone up or have I gone down? Up, yeah. There's been times where I've gone up and times where I've gone down, but overall, we would say that generally you've moved up. So the average rate of change is positive. The way we determine average rate of change is this formula, F of B minus F of A over B minus A. And the way that we represent that mathematically is by what we call the secant line. A secant line represents the average rate of change of a function. Now, this word secant is a little bit odd to you. Maybe you haven't really heard it before, and you don't have to know a whole lot, but do you remember a tangent line from geometry? So you can see over on the board here I have a circle, and a tangent line just touches the circle how many times? Once. And that's what kind of is amazing about calculus is you're going to learn how to find the slope of a tangent line at just 1 point. But slope really requires 2 points, doesn't it? In calculus, we can do it with just 1 point. And it changes everything that we think about with mathematics. A secant line would be like this, where it touches 2 spots. You're like, well, this goes through 3. Well, it could be more than 1 or more than 2. The idea is it connects the beginning and the end. Now, I'm going to show you that you already understand this by labeling this right here. We call that the x value would be A, and the y value would be f of A. And then this next coordinate up here would be B and f of B. I'm going to rewrite this just one more way so you can make a connection. This A value is an x value. This f of A value is a y value. B is an x value. F of B is a y value. Or in other words, x1, y1, x2, y2. So if I replace f of b and f of a and b and a with x, x1, y, y1, stuff like that, what does the formula look like to you? F of b, what do I put in its place? What do I put in place of f of a? Yeah. It's the same thing as slope. Your average rate of change formula is the same thing as a slope formula. They're 100% the same. It's just the way we think about it and talk about it, okay? So let's find the average rate of change of this function right here, okay? What is your y sub 2 value of this function right here? What's the height at this dot? 2. Minus, what's my y sub 1 value? -3. What is your second x value? 4. And what's your first x value? And so I have 2 minus -3 is 5. And I have 4 minus -5 is 9. So that means that the average rate of change is 5/9. Okay? And that's that. We determine the average rate of change. Pretty simple, huh? All right, let's do a concrete example. It says determine the average rate of change of the function over the given x values. So we're going from -2 to +4. So the interval from -2 to 4, that's an interval. That's not a coordinate. It's not a coordinate. If I want to look at the coordinates, I would consider -2 and +4, and I would come up with y values. How do we come up with the y values? Plug them into the function. Very good. 4 times -2 is -8, -3, -11. 4 times 4 is 16, -3 is 13. So I do y sub 2, 13, minus y sub 1, -11, divided by 4 minus -2. 13 minus -11 is 24, and 4 minus -2 is 6. 24 over 6 gives me 4. Are you surprised that the average rate of change was 4? Could you have determined ahead of time that the average rate of change was 4? Why? Because it's a line, isn't it? If it's a line, the average rate of change is always the slope. Yeah. Okay. You try this one on your own. This one is not a line, it's a parabola. See if you could go ahead and identify the average rate of change on your own. Okay, so you should have, the answer came out to be 4. Did everybody get 4? Any questions there? Pretty straightforward? Okay, now let's look at a graphical representation. It says identify intervals on which the functions are increasing and decreasing. So I have increasing, I have decreasing. Right now, is the function increasing or decreasing? Increasing. So it looks like I'm increasing from a value of -5 all the way to a value of what? Where does it stop increasing? -2? And then, is it increasing or decreasing now? Decreasing from -2 to what? 2. And then it kind of just stays flat. Slope of 0 is not increasing or decreasing, is it? It's neither. But it does start increasing again, and it starts increasing from 4 to 5. Pretty straightforward. Increasing. Looks like I have an arrow on the end here, so I'm going to go from -infinity to +3. And decreasing, looks like I'm going to go from, whoop, I'm sorry, I wrote +3. That should be a -3. Decreasing from -3 to what? Over to 1. And then I increase again from like 1 to 4. Now the last piece that we want to talk about is that if you notice, interesting things happen here and here. This is what we would call a local maximum, which means it's not necessarily the biggest spot on the graph, but it's the biggest spot compared to everything immediately around it. So if you look at that area that I circled, this is the biggest spot compared to everything immediately around it. Same thing here. This is what we call a minimum. It's smaller than everything else immediately around it. And so we want to find those spots because that's interesting where it changes from a maximum to a minimum. Now here you could look at the graph and determine it pretty easily, but what about an example like this? Sketch the following graph using a calculator. Identify the intervals on which the functions are increasing and decreasing. So I go into y equals, and I'm going to type in my x cubed. minus 9x. Let you get that typed in. Had a little break from your calculator over the past 4 days, right? It's okay. You get time to get reacquainted with it. I tried to not do any schoolwork either over the past 4 days. Try to get a break. So we're going to have plenty of it the next 9 weeks here. If I want to see a standard viewing window at 10 by 10, what do I press? Zoom what? 6. That's going to bring us all to a 10 by 10 window. I'm not particularly a fan of not being able to see the top and the bottom. So if I go to my window, will I adjust the y values or the x values if I want to see the top and bottom? The y values. So instead of going negative 10, I'm going to go down to negative 20. Maybe that will help me see the bottom. Instead of doing positive 10, I'll do positive 20. Maybe that will help me see the top. And scale just means how many tick marks you want. I'm going to have a tick mark every 10 units. So that would be only 2 tick marks on that graph. I press graph, and is that a better picture for you? I agree. So I'm going to draw that graph. We want to identify intervals on which it's increasing and decreasing. Well, it looks like it starts increasing. So from negative infinity to something. But I'm going to have to find that maximum. Anybody know what I do on my calculator to find a maximum? Second, calculate. Minimum and maximum. Very good. So YouTube Nation, we have people respond with 0, a value, because we've done those operations recently. Because that's what you had on the test, right? But now you can see we're going to use our minimum and maximum option. So it's sitting there right in front of us. So we're going to grab number 4. And I go to the top. And it asks me for a left bound. So I'm going to move to the left of that spot, press enter. I'm going to move to the right of that spot and press enter. I press enter on guess, and it produces a value of negative 1.73. So it looks like I'm increasing from negative infinity to negative 1.73. After that, it looks like I start decreasing from negative 1.73 to, uh-oh, I got to find the bottom now. How am I going to do that? Second, calculate, and I grab minimum, which is number 3. Go all the way down to the bottom here. It asks me for the left bound, so I move to the left. Press enter. Now I move to the right. Press enter. And I press enter on guess. 1.73. And then it increases after that. So from 1.73 then to infinity. So those are my intervals of increasing and decreasing. Pretty straightforward for you? Any questions? Okay, let's do our last function then. How do I graph that? This is what I'm really excited about, is that right now you look at this and you're like, how do you graph that? By the time the week's over, you're going to be able to look at that and you're going to be able to know what the graph looks like within 5 seconds. And I'm not kidding. When I look at this, I used to look at this like you did. I used to be like, boy, I wonder what that looks like. And then you learn certain tricks. I'm going to show you all those tricks the next couple days, and you're going to see this. You're going to be like, oh, I know exactly what it looks like. Okay? That'll be kind of cool. I'll even show you a little bit right now. But let's just type it in. I go -2. And then to grab a cubed root, I can press math. And you can see the cubed root option is number 4. So I got the cubed root of, and I do x minus 3. I close that parenthesis, and then I add 1 to it. And I'm going to view it in a 10 by 10 viewing window. So I'm going to do zoom standard so I get back to a normal viewing window. So that's my graph. Increasing or decreasing? How about here? How about here? How about here? Sure seems like it's always decreasing, right? Except for one spot. What does it look like it's doing right here? Looks like it's going straight up and down, right? And if you think about it, we have four kinds of slope. We have positive slope, we have negative slope, we have zero slope, and then we have this kind of slope, which is undefined. And so if you have a vertical line, which we do in this situation, we would say that it doesn't have slope or an average rate of change there. Now, what is the x value that you think that happens at? About 3. So we would say increasing, never. Decreasing, we're going to say that that happens from negative infinity to negative 3. I'm sorry, positive 3. Union with 3 to infinity. So that way we leave 3 out of the mix. Now, Josie did ask what it looked like, and I'm just going to show one small piece here to tell you a bit about how it looks, okay? Notice that we said it looks like it's over 3. Look at what the horizontal shift of the graph is. 3. Look at the y value. It's up 1 unit. It's shifted up 1 unit. And the negative on the outside actually reflects it from going like that. So there's some pretty easy ways I could show you exactly what it's going to look like. So, okay, good job today, folks. Hopefully a pretty quick lesson for you. Your assignment is, oh, got to make sure I put this in YouTube. Okay, 2.4, page 182, numbers 1 through 6, 13 through 19, and 27 through 32. This should be a pretty straightforward assignment. Should not take you real long. Should not be real complicated. You do get worksheets most of the rest of the way through. I think I have 3 worksheets for us the rest of the way here. A couple book assignments, but 2.5 is going to take us a long time to get through. Definitely the rest of the week. But if you are behind in your math homework, it's going to be a really important time to get caught up. If you haven't learned how to graph piecewise functions yet, you really want to make sure you come and see me and learn how to do that. That's going to be a tough piece for you to do if you haven't looked at it yet. So get reacquainted with math, and we'll see you tomorrow.